All right, this is FRQ number 2, part C. All right, so it says the function h satisfies h of x equals x squared minus 4 divided by 1 minus the quantity f of x cubed for x not equal to 2. All right, it is known that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. All right. Use the limit as x approaches 2 of h of x to find f of 2 and f prime of 2. Show the work that leads to your answer. All right, so we got to remember something about L'Hopital's rule. All right, what does L'Hopital's rule say? All right, that if you are trying to evaluate the limit as x approaches 2 of h of x, right? Now, if you do that, right, what's the first thing that must be true? Is that separately, all right, the limit as x approaches 2 of x squared minus 4 must be equal to 0, and the limit as x approaches 2 of the denominator, 1 minus the quantity f of x cubed, must be approaching 0 as well, right? And so that is true, right? Then what must also be true is that x squared minus 4 and 1 minus quantity f of x cubed are continuous and differentiable at x equals 2. All right, so obviously x squared minus 4, that is, but what isn't obvious is that this limit would equal 0 and that 1 minus f of x quantity cubed, all right, is continuous and differentiable at x equals 2. All right, so, all right, we know then that since those things are true, we can find the value of the limit as x approaches 2 of h of x. All right, now, all right, so h is differentiable, which you were told, right, at the beginning. All right. And so that means that h is continuous, right? And since h is continuous, that means that the limit as h approaches 2 of of h of x exists, which also means that h of 2 exists. And that means that those things are equal, right? So the limit as x approaches 2 of h of x is equal to h of 2, which you are told at the beginning is 4. So you know that this limit equals 4. All right. Now, okay, a couple of things that we've already talked about. Okay, we've talked about that this limit as x approaches 2 of 1 minus f of x cubed is equal to 0. All right, and so what does that mean? Well, that means, all right, that 1 minus, the limit as x approaches 2 of 1 minus the limit as x approaches 2 of f of x quantity cubed is 0, right? So we can split the limit. Now, if we say this, then we can say the limit as x approaches 2 of 1 must equal the limit as x approaches 2 of f of x cubed, right? And so now we could also use the fact that if you have the limit of f of x cubed, you can say that that is the limit as x approaches 2 of f of x, right, cubed, right? So we can bring the cube on the outside. Now, that equals the limit is x approaches 2 of 1. That's just 1. And so if I cube root both sides, I get that 1 is equal to the limit as x approaches 2 of f of x, right? Now, since f was continuous, that means that the limit as x approaches 2 of f of x equals the value of f of 2. And so f of 2 must equal 1. All right. So you were told, first of all, to use the fact that the limit as this limit to find f of 2, which we have. F of 2 is 1. All right. And so now we want to use that limit also to find f prime of 2. All right. So now f prime of 2 is going to be associated with L'Hopital's rule as well. All right, so let's continue. All right, you know that the limit as x approaches 2 of h of x is equal to 4. And you know that h of x is this, so we can say that the limit as x approaches 2 of x squared minus 4 over 1 minus the quantity f of x cubed is going to be equal to 4, right? Because we said that the limit as x approaches 2 of h must equal h of 2, which is 4. All right, so now you know that according to L'Hopital's rule, because x squared minus 4 is that limit equals 0, and the limit as x approaches 2 of 1 minus f of x cubed equals 0, and because x squared minus 4 and 1 minus f of x cubed are continuous and differentiable, okay, we can use L'Hopital's rule. And so we can say that the limit as x approaches 2 of 2x divided by the derivative of the denominator, so that would be negative 3 times f of x quantity squared times the derivative of f of x, which is f prime of x. All right, and that is once again still going to equal 4. All right, so now we're going to plug 2 in. So we get 2 times 2, which is 4, in the numerator, over negative 3 times f of 2, which we just figured out is 1, squared times f prime of 2. All right, so that equals 4. All right, so now we just have a little bit of algebra. So if I multiply both sides by f prime of 2, okay, so I get f prime of 2 equals, now if I divide both sides by 4, the 4's will cancel out. All right, and so I'm left with 1 over negative 3 times f of 2 squared. F of 2 is 1 squared. So f prime of 2 must be negative 1/3.